back, and so what I've written up here on the board is the linear concepts over here, and then the angular or rotational concepts are over here. So we have linear distance measured in meters, linear speed measured in meters per second, linear acceleration in meters per second squared. And then over here, we've got the rotational counterparts. So this is rotational distance because it's the angle through which the tire rotates. And then that's in radians. Then this is rotational speed in radians per second. And then this is rotational acceleration in radians per second squared. Okay, now the next thing that we learned in a previous lesson when we talked about linear motion, when something is moving in a straight line, we found that there were three formulas that were very, very useful in explaining linear motion. So the top one there is going to be the how far equation. So I'm not going to bother to write it down again, but it says that how far something travels is going to be equal to its original speed multiplied by time plus 1/2 its acceleration times time squared. And we called that the how far equation because it tells you how far do you go. Then the second equation is going to be the linear version of the how fast equation. And it says that how fast you're going is going to be equal to how fast were you originally going plus your acceleration times time. And then we said that there was a third equation, which I said don't worry about, okay? But there is a third equation that you can get by solving the first two equations for the letter T and then putting them together. And then that equation is called the hybrid equation, which says that your linear final speed squared is going to be equal to your initial linear speed squared plus 2 times your linear acceleration, and then how far do you travel? So that's the delta R. Now, notice that we could have identical looking equations when something is rotating. So that first equation over there in orange would be the rotational how far equation. And do you see that everywhere that there was an R, what did we do? We plugged in this. Everywhere that there was a V, we plugged this in, and then everywhere there was an A, we plugged that in. And then you could also have the rotational how fast equation. And we did the same thing. So we took the linear how fast equation and we substitute for V the omega, we substitute for the A, the alpha, and we get that. And then you can even have a rotational counterpart to the hybrid equation. All right, now the good news is we're not going to do it. All right, it's not going to, for you, if you're one of my students, don't worry about it. Okay, now you should know, though, how to use the linear how far and the linear how fast equations, the ones that are in green. So equation 3.3 and 3.7. You should already know how to use those. But we could solve problems in which you've got a spinning wheel and you wanted to know how many times would it go around, how fast would it be going, and we could do that by using the rotational counterparts to the linear how far and the linear how fast equations. So if you go on to take more upper level physics classes, you would be using those equations. So I just wanted to show it to you so that for everything that we've been talking about with linear stuff, there's something that goes with it over here with the rotational stuff. Okay, got it? Okay, good. Let's take a break. So when we come back, we're going to talk about how to connect linear concepts with rotational concepts.